so next, let's move on to the next segment. In this one, we're going to talk about region-based approaches for image segmentation, and we'll cover like two different approaches. The first one is we will try to merge different pixels to actually grow these regions. And the second is that's kind of a top-down approach where we'll try to split like different regions to create these smaller segments. Okay, so both are kind of reverse of each other. And the high level idea remains the same. We want to find these close boundaries, right? And again, we'll have to use some kind of similarity measure between the pixels, the neighboring pixels, to say that they belong to the same group or not. Okay, so the first one is region growing, and the idea here is we'll just rely on the color information, let's say, or the pixel intensity for now. Now, what we do is we start from like any random pixel, which we can say like a seed pixel, and we look at the intensity of that pixel, or you can see the color of that pixel if it's a colored image. And what we try to do is we try to look into the neighborhood, and if we see that okay, there is like some similarity with the neighborhood pixels, we will try to add the neighborhood pixels to the current seed pixel, and we'll keep doing that until we see the similarity metric, the similarity threshold is actually meeting. Okay, so that's kind of region growing. And we can have like certain criteria. For example, we don't want regions to grow too much, so we can have limit on like number of pixels we can have in each segment, or we can set like some kind of threshold, like what should be the threshold when we compute similarity between two pixels. Okay, so that threshold will play a very important role when we create these regions. Okay, so as I said, like similarity criteria, I mean, that's alone is not sufficient. We also need like some kind of adjacency neighborhood, and I will explain like why. Because what might happen is, for example, if you just look at this slide over here. Okay, now if you look at this pixel, it's purely white, right? And then look at like this top right pixel. Again, this is also pure white. So ideally, if you just have to look at like the color information, then these two should be like the same segment. But ideally, we don't want like pixels that apart to form like a same segment. I mean, it won't look good. What we want is we want like neighboring pixels to be close to each other, right, to form a segment. And if to give like an example from a real world, if you have an image, let's say where you have trees, okay, so you might have a tree on the left bottom, you might have a tree on the top right, and of course the colors will be similar because both are trees, but then they will be like different segments because they are not close to each other. So that's why the spatial relationship or the closeness of those pixels is also very important. Okay, so again, this is a very simple algorithm which I explained like in just 2 sentences earlier. What you have to do is you have to find like distance between the similarity measure, which could be just the intensity of the pixels, and use some threshold to say that, okay, they belong to the same segment or not. Okay, and then we keep storing like some kind of a running average. You can say, like if you have, let's say, accumulated 10 different pixels and all of them were like within some range, but what we want is we don't want to like keep adding pixels with that variation, right? So we try to keep some kind of running average, which says that, okay, this segment has a mean color of or a mean intensity of this value. And the reason for that is, let's say our threshold is, let's say our pixel intensities can vary from 0 to 255. All right. Now, let's say we set a threshold of 5, which says that if two neighboring pixels have intensities where the difference is less than 5, we will say it's the same segment, right? Now, what may happen is you might have one pixel intensity 5, then you might have a neighboring pixel intensity 9, then intensity 13, 17, 21, you can go all the way up to 255 with a gap of just 4. If you don't use running average, then what will happen is all those pixels will be just like one segment because they were meeting the threshold and they were adjacent as well, right? So because and that's kind of a gradual increase or a gradual decrease. So to take that into account, we need to keep like a track of the running average. And then what will happen is after some point, you might, let's say you start with pixel intensity of 5. Let's say you reached until 40 or 45, your average will be like close to maybe 20, 25, right? And then you won't meet that criteria of the difference of 5. So that's like one simple example why we need this running average. And the other issue is like we don't want our segments to grow too big. All right, so then the third step is like, again, this is looking into the standard deviation again within a region. And again, you can set like some kind of threshold on that. You say that, okay, when you're adding some pixel, the standard deviation should not increase this particular threshold. Okay, so you don't want to add like some kind of outliers into your segment. And again, all these are heuristics, so you can use these heuristics to design your algorithm. Now, let's quickly run through like how it will look like. Okay, so you'll have to first start with like a seed pixel, let's say, and again, it's done randomly. So let's say you start with this underscore. And then let's say you have some kind of, so again, you will have to have those thresholds, right? One threshold could be based on pixel intensity. It should not be higher than that. And then of course we will keep like the running average. Then again, you can use like some kind of threshold for variance as well. If adding this pixel is actually changing the variance a lot, then you won't add that pixel. Okay, and of course, we'll just look into the neighboring pixels. Now, if this is your seed, then of course you can see that this is 1. So definitely this is the segment you're going to add to this pixel. Again, this is 1. So you will keep growing those. And again, if 0, if a threshold is less than 1, all values will 0 will be added. And again, if it's less than 2, this I think is also going to add. You can see like at the end, you are getting these two regions. One is A and the second one is B. Okay, and you can see, I mean, kind of the A was coming from this 1 as a seed, and the second region is coming from this 7 as a starting seed. Okay, and the reason will be beyond this column, like all these pixels have like values greater than 2, right? So they won't meet that threshold. So the way it will work is you will start with one random seed, let's say this, you create a segment, and then you're done. You can't add more pixels. Then again, you will start with a random seed. Let's say this one, you will keep adding, and then you are done. So, and you get 2 segments. If more pixels are remaining, you start again. Okay. Now, some interesting examples like where this can be useful. This is a CT scan. And so let's say this was your starting pixel intensity. Then you will get like some kind of segmentation like this. And again, this is just based on like the intensity of each pixel. Okay, if you're interested in like this segment, you start like at this location and you will get this segment. So you can see that how this can be very, very useful for doctors. And then in this case, like having a random initial seed is not an issue because the doctor will know exactly like which segment they are interested in. If they're interested in this segment, they can just select it. And then the algorithm will give the segment. Okay. So yeah, again, I think this is just like a run through of the same approach we just discussed. And I think in interest of time, let's skip this part. And it's doing the same thing. So let's say this is the starting seed. And it's adding the neighbors, right? And then depending on the value, it will keep adding and it will keep growing, right? So in the first step, it's just adding the neighbors, all the circles with -1. And then it will start with this one and it's added at the segment and it will add one more neighbor, right? So it will keep doing that until all of them are added to the segment. Okay. So it's just showing like the run through. Yeah, we can skip this. This is just trying to compare like what will happen between thresholding and region growing. And so one, like at a high level, I can tell you the difference. So in threshold, you really don't care about like the spatial adjacency or the closeness of those pixels, right? That's kind of never taken into account. For thresholding, all you look into is the pixel intensity, and you just say whether it's a foreground, it's a background. But in region growing, if you think about this, you are actually taking the spatial proximity of those pixels into account. Okay, so it's more likely that your regions will be like more coherent, or they will be like in the same spatial proximity, okay, as compared to your thresholding. In thresholding, it might happen is that pixels which are far apart in the image might be considered as foreground or background, but that will not happen in region growing, and that's one of the biggest difference between these two algorithms.